training in weld quality assurance and quality control. Section 5, Destructive Testing Methods. This section of the Weld Quality Assurance and Quality Control program provides a description of the properties of metals and welds and the destructive testing methods used to evaluate these properties. Topic number 1, Introduction to Destructive Testing Methods. The objective of this topic is to know the mechanical properties of metals and welds and the type of tests used to evaluate these properties. Destructive testing is an evaluation process for weld or base metal specimens and takes place during or after the destruction of the specimen. Destructive testing is a function performed by quality control to measure the properties of metals and welds, of which soundness is one of the most important. The term soundness is commonly used to describe the weld's degree of freedom from discontinuities. Cracks, inclusions, porosity, and lack of fusion reduce weld soundness and may prevent the weld from performing in service. In addition to soundness, the mechanical, chemical, and metallurgical properties of the welded joint are also important to the reliability of the weldment during service. In design, materials are selected to provide these properties. The process of welding must allow the materials to maintain these properties by the development and use of a proven procedure. Welding codes use a variety of destructive testing methods to evaluate materials so that design performance requirements can be met. These tests are also used to determine the quality of welds produced by specific procedures, so that the procedures and welders can be qualified. Destructive testing can also be used to spot check the quality of production weldments by evaluating random selections of welded parts. This is commonly known as work sampling. Destructive testing has evolved into specialized methods which can determine the mechanical, chemical, and metallurgical properties of welded joints. The most important mechanical properties include strength, ductility, toughness, and hardness. One important measure of strength is the material's ultimate tensile strength. This is determined by subjecting weld metal or a welded joint to a pulling load until it fails. The maximum stress developed is a good indication of the amount of load the material can sustain. Yield strength is another important measurement of the material's load-carrying capacity. This is the stress at which the material will permanently change in dimension, usually length and cross-sectional area. This property is an important consideration for structural weldments such as buildings and bridges. Ductility is the property which allows metals to be drawn or stretched without rupture. A ductile material can be bent. A material which is not ductile is referred to as brittle. Brittle materials will fracture suddenly when bent. Steel and cast iron are both strong metals, but cast irons are usually more brittle than steel. Toughness is the ability of a material to sustain a sudden shock loading at various temperatures without failure. The energy absorbed by the specimen will vary depending on temperature. For instance, the toughness of steel will decrease as the temperature is reduced. Toughness is an important property for pressure vessels, which are designed to operate in wide ranges of temperature. The property of hardness is the metal's resistance to indentation from the force of a hardened substance. Hardness is measured by forcing a hardened steel ball or a diamond into the surface of a metal. The Brinell, Rockwell, and Vickers tests are commonly used to evaluate this property. Although not a common test for weldments, it is sometimes used with weldments which are subject to wear. For example, a bulldozer blade requires resistance to the materials which strike against its surface. Destructive testing also includes chemical tests. Welded joints may be cut to remove sections for analysis of alloying elements. Specialized equipment in laboratory conditions, such as spectrographic analysis, can be used to evaluate chemical composition. This is important to filler metal manufacturers, where electrodes must be produced to meet minimum alloy requirements. Chemical composition is important for weldments requiring corrosion resistance. Chromium and nickel content, as well as carbide formations, are analyzed to determine the metal's ability to perform in surface. Destructive tests are also used to evaluate metallurgical structure. One method consists of cutting a specimen, polishing the cut surface, applying an etching acid, and visually inspecting the etched surface. Variations of the process include viewing the surface with different degrees of magnification. This could range from visual inspection with the naked eye to 250 times or higher. This is known as macro or micro examination, depending on the magnification used. The etched surface is inspected with or without magnification to determine the following properties: soundness, grain structure of the weld, fusion zone, and heat-affected zone, weld pass arrangement or bead sequence, and penetration. The remainder of this section is divided into 6 topics, each dealing with the principles and practical use of the following destructive testing methods: tension testing, impact testing, the guided bend test, the nick break test, the fillet break test, and etch test. These methods will be used to evaluate the properties of filler and base metals for selection purposes and fabrication method. In conclusion, destructive testing can be a very effective tool for determining weld quality if the destructive testing procedure is established, specimens are properly selected and prepared, and the results are evaluated in accordance with prescribed standards.